to the study of angles and triangles where you are dealing with two different types of triangles. You have one which is a right triangle, and you have one which is an oblique triangle. All right triangles, remember, have one angle that is equal to what? 90 degrees. Okay, so any triangle that has an angle of 90 degrees in it is a right triangle. We have oblique and acute triangles. In essence, they're kind of the same thing, because if you have one angle that's oblique, you're going to have another that's acute. They just kind of mess up the terms on them. But when you have those, we have a different trigonomic identities, I guess would be the correct way of saying that, to solve for those. And we're going to pick those up in days in the future. In essence, we're going to deal with what's called the law of sines, law of cosines. Those are for another day. Right now, we will focus on nothing but right triangles. Before we get into that, we need to do some definitions. When we look at angles, really in essence, what are we talking about with an angle? We're talking about how lines intersect and the angle that they intersect. So in essence, if we know how lines are joined together, then we should know what that angle is based on the length of those lines. And that's exactly what trig is. And they've defined some terms to show this relationship. And they're all dealing with triangles. Now the terms they've defined are these right here that you see at the top of the page. Sine, cosine, and tangent. Now these are just terms that explain the relationship of the sides of a triangle. Okay? That's all they are. So when I talk about sine, what I'm really talking about here is the relationship of the opposite side to the hypotenuse on a triangle. And whatever those lengths are, that relationship, the angle has to be forced based on those lengths. So in essence, if I'm looking at this one down here, and I'm looking at, let's say, that angle, if I want to know what this angle is, I can look at the opposite side, which is this one, in relationship to the hypotenuse. And that will define that angle. Okay, because you can kind of see it if I take this side and I extend it out, what happens to my hypotenuse? It then gets longer also, right? Mm-hmm. But that ratio stays constant wherever we go for whatever angle is going to be there. So if I know what that lengths are, I should be able to back calculate out what the angle is. Or conversely, if I know what the angle is on one side, I can figure out what one of those lengths are. So that's what we're dealing with sine. Now, if I'm also dealing with this angle right here, and I don't have this information, I can use a different relationship because that's only one of the possible combinations of these sides. Remember, these are all connected. If I know this one and this one, I should still be able to figure out that angle, because that's going to dictate the other side. So I would use what's a term called cosine, which looks at the relationship of this side to this side.
Wait, but what angle were you talking about?
It would be this same angle.
The same one?
Same one. It's still dictated, since these are all joined together. If I know the length of these two, I know that angle. But I have to use this proportion, cosine. Now that gives me two of my three possible combinations of these sides and how they work. We need one more because there's one more possible combination. Therefore, they came up with tangent, this one right here. Again, same angle, but now I'm looking at the last remaining possible combination of these sides, which are the opposite and adjacent. And again, if I know these lengths, this angle is forced. I know it also. Okay? So in essence, just keep in mind these are terms that relate to the length of sides in some combination of a triangle. Yes?
Could you repeat about the tangent one again? Which angle would it be? The same one?
Same angle.
What?
Yep, but now it's based on the information you have here. I mean, that's what we're looking at. What's our known information?
Okay.
So I can either look at this relationship, or that relationship, and that's all possible combinations of two of these sides of the triangle. I can look at any of those combinations and solve for that angle. So when we talk about these, sine, cosine, tangent, keep in mind we're just talking about a relationship of sides in some configuration. Okay? Now, one thing I do want to point out, I kind of mentioned we were dealing with this angle because it matches what they're doing here. What if I'm talking about that angle? We can still do that. We don't need to deal with this one, it's 90. Okay? But this one, exact same relationships, but we need to label our triangle different. Okay? So if I'm right here, the hypotenuse always has to be the hypotenuse. But since I'm dealing with that one, this is no longer a side that is opposite this angle. It's now adjacent to it. By adjacent, I mean next to it. Okay. So I'm dealing with that relationship. This side is opposite the angle. So therefore, it changes to my opposite side. So you do need to label your triangle properly depending on which of those two angles you are trying to use to solve for information on this triangle. Yes?
The hypotenuse is always going to be the longest one, right?
Always. That never changes.
The only ones that switch is adjacent and
I'm sorry?
the only ones that switch is the adjacent and opposite.
That's correct.
And adjacent means next to. So okay.
Yep. You might want to think of this on a geometric principle that we talked about last time we met, where I took, again, a right triangle, and I used the Pythagorean theorem, okay, where the C was the hypotenuse, and it was always the hypotenuse, right? And then we could label the side A or B, or A or B. It didn't matter, right? That one doesn't matter. With this one, again, you do have to get the adjacent and opposite sides correct for the angle you're looking for, but they will move depending on the angle you are dealing with. We'll come back to that more in a minute because I've got a really, I think, an all-encompassing cheat sheet for you to use on this, and we'll get into that in a minute. Now, to make sure we're using this correctly, let's just come down to this triangle down here, our standard 3, 4, 5 that we've talked about already. They've defined an angle for you right here. Let's make sure our calculators are giving us the right answer. We should get the exact same angle for this because I know all the sides regardless of what I use here. So I'm just going to say, since we're dealing with this angle, this side right here, the 5, it has to be the hypotenuse, correct?
Yeah.
Okay. Now, the side that's labeled 4, what is that going to be labeled?
Adjacent.
Okay, that's going to be my adjacent side. And I guess I won't ask on this one, because that's opposite. Okay, now, let's just prove that this works. So I want to know what this angle is, so I'm going to do the sine of, now I got to come into arc sine. We need to do one other definition here. We've got to do what an arc sine is.
Arc sine?
Yes. So if I have 1 divided by a sine function, which sine, remember, that's just a number, it's a proportion of two sides together. We will see this written as sine to the minus 1.
Oh, yeah.
Have you seen that?
Yeah.
It's probably on your calculator. This is just a power of a -1. It's just rewriting this equation. Instead of writing it 1 over sine, we write it as sine minus 1. They're the same thing. We call this arc sine. If I have cosine to the -1, I call it arc cosine. If I got tangent to the -1, I call it arc tangent. And all it's meaning, hey, I've got it in the denominator versus the numerator. We're going to need that to run this equation. Because here's what we're going to do. We're going to take the sine of some angle is equal to, for this one, we'll plug in our numbers. Okay, which two numbers am I going to use here? Okay, you know the sine's equal to opposite over hypotenuse. Come down here where I've got this triangle, which side's labeled with opposite? Okay. Is it? Here's my angle. I labeled the sides. I don't know if you can see them through Amanda's screen. That's labeled adjacent side. That's labeled the opposite side. Okay. Plug in your numbers right here. What's my opposite side? You can see a 3? Okay. What's my hypotenuse?
5.
5. Okay. Let's convert this to a number and rewrite this. So I've got a sine of an angle is equal to, what's that, 0.6? Somebody please crunch your calculator and make sure I...
That's correct.
Okay, thank you. Remember, I want you to always go to 2 decimal places at a minimum. Or, yeah, that's your minimum. Now, how do we get the angle away from the sine? This is one number. That's all it is, it's a number. I've got a relationship of sides term and an angle term. So to get the sine away from my angle, I have to divide, don't I? So I'm going to divide by the sine. What I do to one side, I have to do to the other. Okay. This goes to 1, correct? This side? And I'm left with my angle on this side of the equation. Over on this side, don't I really have, can I rewrite this as 1 over sine times 0.60 over 1? Isn't that the same thing?
Yeah.
Yeah.
It is, mathematically. Okay. Does this look familiar? Right over there? Okay, so what we're going to write this equation as is sine to the minus 1 of 0.60. And all that's saying is I'm going to take 0.6 and divide it by this sine function. Now, once we get to this point, we're ready to go to a calculator and do what I call plug and chug. Okay, we're going to enter our data and get an answer. So a lot of people, their calculators are set wrong when the first time we jump into this, so I want to make sure we get this. So first off, when you're plugging these in, you need to find these 3 keys: sine, cosine, tangent. Declan, would you mind turning off this front light? It's kind of hard to see with. Just touch the bottom of it. Yeah, it should go. Thank you. Now, notice on this calculator right above it, I don't know if you can see that, it says sine minus 1, cosine minus 1, tangent minus 1. So to get into those, I've got to hit my second function key and the same one. That gets me to that other menu. Do all of you see your sine, cosine, tangent buttons on your calculators? So you're going to enter them different ways. Some of you have equation building calculators. This one just kind of works in standard algebraic nonsense. So let me just plug in the numbers of how I would do this in this calculator. So I'm going to hit on this one 0.6, so I enter the value first, and then I'm going to hit second function and my sine key, and it returns me with an answer of 36.87 degrees. 36.87. So I know my angle now is 36.87, and that's degrees. Did anybody not get that number? Raise your hand if you didn't. Okay, the first thing to check is up at the top, is your calculator set to degrees or radians?
Degree.
It needs to be set to degrees. Okay, you're in degrees. That is just a little button. So yours will work the same as mine. So 26. Okay. You gotta do arc sine first.
Sine 26.
36.87. Okay. You're good. There's your sign, right above it is the shift. Okay, yours is a calculator. Computer equation, so put 6 in here. So first click the function, 6, enter. You should be 37.87. Yours is going to build an equation. I think you're using that big T, right? Okay, so what you're going to get is your sine function, arc sine. Function arc sine, then type 0.6 and enter. Here it is. So where's your node? Is usually exactly one node. And 200 degrees. Right here. Okay. So remember that number, 36.87. Now we're going to look at the cosine of that angle. And what two numbers am I using here? Okay, keep in mind, we're on the same. Let me try and line this back up with my, I erased my opposite. We just re-put that down. Hypotenuse, adjacent, opposite. Okay? So this time I'm going to use the cosine. Cosine up above has the adjacent in relationship to the hypotenuse, right? Okay, so we're going to use different numbers here. Here I'm going to do a 4 over a 5. So I have the cosine of some angle is equal to 0.8. Now here's a shortcut for you. Instead of me writing where I'm going to divide cosine by both sides, whenever you got to break these two apart, just immediately do this because it's the same no matter how you're doing it. Cosine minus 1 of 0.8. You're ready to plug and chug. We should get fairly close to 36.87 degrees. Okay.
I have a question.
One sec, let me run this real quick and then I'll answer your question. 4 divided by 5, and my calculator gives me a 0.8, and I hit my arc cosine button, I get 36.87 degrees. Amy, what was your question?
If we were looking for cosine -1, would we switch that also to just cosine? Or will we never be looking for the cosine?
We will be looking for the cosine if we know the angle to start. Here we don't know the angle, so we've got to break that term apart.
Okay, but later on we'll figure out like how to do the angle one.
Yep, in just a minute you're going to figure the angles,
Okay.
that relationship. Did everybody get 36.87 again?
Mm-hmm.
In the interest of time, I'm not going to do the tangent here. But if you do the tangent, which is a relationship of the opposite to adjacent, the other combination, you're going to get the same answer. All right, now to what Amy just mentioned, is how do we use this relationship if we know the side, or the angle? So that same triangle, if I redraw that thing, may put it, wait, it went this way, right?
Mm-hmm.
We now know that this angle is 36.87. This time, we know that I'm going to say this side's a 4, this side's a 3, and I want to solve for the hypotenuse, because I don't know the hypotenuse. What I'm going to do is I'm going to look in those terms and say which one can I use where I've got the hypotenuse in that equation and it's undone. I can use, in this case, sine and cosine. You can't use tangent because it doesn't have hypotenuse in it. So there's no reason to solve the tangent one. So I'm going to use sine. So I know that the sine of 36.87 degrees is equal to sine, opposite over hypotenuse. Okay. Again, here's my opposite. 3 over my hypotenuse. Now on this guy, we've got to do a little rearranging, because I need to get the hypotenuse in the numerator and on one side of the equation all by itself. Requires some algebra. So keep in mind, all we're doing is trying to isolate. Kind of like when we figure out the DSF. What do we try and always do? Get our units the same, one in the left side of the equation. It's kind of what we're doing here. So how do I get the hypotenuse into the numerator? It's a divide term, so I've got a multiply. So I'm going to divide this side by hypotenuse, this side by hypotenuse. Or excuse me, times. I think I said divide, didn't I? This hypotenuse turns to 1. Let me rewrite this equation. I now have the hypotenuse times the sine of 36.87 degrees is equal to 3. Now, we need to now move this to the other side of the equation. Since these are times together, I need to divide. So I'm going to divide by the sine of 36.87, both sides. That goes away. Let me rewrite this equation. My hypotenuse is equal to 3 over the sine of 36.87. We're now ready to plug and chug. So let's make sure we can get the right answer out of our calculators. So here, what I'm going to do on mine is I'm going to hit 3 divide. Now most of you are now going to hit the sign button. Like Declan, Juan, Lisa, you're all going to hit the sign button here. I'm not. So I'm going to hit 36.87, and then I hit my sign. That gives me a number, and then equals. And I should get 4.999999,
So 5.
which is 5. Can everybody get a 5 out of it? Okay. All right, if you go to the back of your text, the second to last sheet, you're going to see this page. Second to last page at the back of your book. I'm not sure I'm going to get all the way through this today, but we're going to try. I'll talk very fast. Put together this cheat sheet. Love cheat sheets, especially with math. You get to use this cheat sheet on your tests, right? Or any pop quizzes, which we might find one of those next week.
Pop quizzes.
I always give them away. I just can't. It's kind of like my daughter with Christmas. I mean, she cannot wrap a present and not tell me what it is. Cannot do it. I know everything I'm getting every year. Up
Do you
here,
act surprised though?
yes, I still do. Even though she's 23 now. Up here is right angle trigonometry. We're going to go over how to use this. Down on the bottom is the Pythagorean theorem, which is a valid equation for right triangles. We talked about the Pythagorean theorem. It's only used to solve for length and sides, and I need to know any two of those sides to solve for the third. I don't plan on repeating this, okay, but know it's here and how to use it. If you have any questions, come see me. We'll go over it again. Up here, what we're doing is basically the hard part here is knowing how to label your triangle. So I've given you both possible combinations. I have a right triangle where I deal with this side. That's always labeled adjacent. That's always opposite. That's always hypotenuse. If we look for the other angle, these two sides switch places. So there's how you're going to label your triangles. After that, you're going to basically use an acronym that we call SOHCAHTOA. I didn't put the other acronym I know on this because it's not pertinent for this environment. But if you get out there, some math geeks, they come up with some other ones. Okay, this is an acronym that will help you to memorize this relationship. Okay, SOHCAHTOA.